Welcome to Sundar's lecture. This is lecture number 9, and in this lecture we are going to see basics of Karnaugh Map. How we are going to implement a Boolean expression into Karnaugh Map, and what are all the basic things in different variable Karnaugh Map, right? So what are all the topics we have seen in the previous class, because these kind of basics are very important to understand the Karnaugh Map technique, right? So the thing we have seen in the previous class is min term and max terms, and how we need to represent a POS function in max term and a SOP function in min term, right? So that is what we have seen in the previous class. Suppose they have given you like this, which means summation small m 3, 5, 7, then it actually representing this expression. That we will do it a bit later with the Karnaugh map. And also, if they have given you a symbol like pi, it is actually not pi, it is a multiplication symbol. Pi of m, pi m of 1, 2, 3, 5, then it actually represents this POS function. That is what we have seen in the previous class. Now, in this class, we need to see the basics of Karnaugh map. Before going into that, we need to know what is gray code. Actually, gray code, and I will explain you what is gray code in my future lecture. While going for code conversion, we are going to see binary coded decimal, gray codes, and then we are going to see some other codes also. But before that, I'm not going to explain you exactly what is gray code right now, because I will explain you a bit later. But what is gray code? In successive numbers, one bit change will be there. One bit change will be available, right? That is we are calling generally as gray code. You try to understand, that's all. This is enough for now, and then I will explain you what is gray code and how to convert BCD to gray code. All those kind of things we will see in the future lectures, right? So anyhow, so this is the basics, and what we are going to do, we are going to see for one input system, and we have seen these kind of things. That is why I have told you in my previous lectures, I will say always one input system, two input system, three input system, and you have to understand, right? So for example, if it is a one input system, so what you will have, only one input, so it will be A, only A. So this A can be either 0 or it can be 1, which means this is A bar and this will be A, right? So how you need to draw the Karnaugh map? Simple, very simple. You draw like this, and then that's all. You can just split this one and you put the variables. This is 0 and this is 1. This will be A, and this will be A bar, and this will be A. So wherever you see 0, you put bars. That's all. So there are only two inputs are possible, that is 0 and then 1, and the variable will be, this is A bar and this will be A. That is the whole idea, right? So now what we will do, we will go for two input system, or they will commonly call this as one variable K-map, two variable K-map, anything it may be, no problem, right? So if it is 2, then it will be 2 power 2, then you will have 4 number of combinations, right? 4 number of combinations, so it will be A and then it will be B, right? So what is 4 number of combinations? 0, 0, 0, 1, 1, 0, and this will be 1, 1, right? So how you are going to draw the Karnaugh map? Now we will have 4, maybe see here, how you can write this one right now, because this one, whatever we are doing now, is only applicable for SOP functions, not for the POS functions. For POS function, I will give the basics with a different lecture, with a different kind of explanation, right? Whatever we are doing, this one, whatever we are explaining now, only applicable to SOP, sum of product functions, right? Sum of product. And with this basic, we can easily understand what is the POS function too, right? So this is the 4 input system. So for example, you have an output like Y to understand, right? So if you are giving this input, if I am giving 0, 0, the system output will be 0. And if I am giving 0, 1, the output will be 1, 1, 0, the output will be 1, and 1, 1, the output will be 0. For example, you just try to understand, and I will explain you what is this output and how it is coming down. All those kind of things we will see bit later. But for now, you try to understand. I have an output. If I give this input, this is the output, right? So then what will be the expression? What will be the expression? See how you need to write this one. Maybe this y. Y can be written as, wherever you see 1, you have to take this expression. What is this one actually? This is a bar. If it is 0, then put a bar. And if it is 1, then put a b. That's all. Since it is a SOP function, you have to put plus. Straight away you have to put plus. And then you have to write for this one. You see here, this is 1, this is a, and this will be b bar. This will be b bar. This is the actual representation for this particular output. For this particular output, if they have given you like this, then you can convert that into a truth table. These kind of things also we have already seen. So this is now my Boolean expression. And for example, if it is a 2-input system, then how you are going to draw the Karnaugh map? That is the whole idea. See here, you should have 4 number of combinations that should be written here. So you just draw like this, and you split like this. That's all. Now you just split this one like this. And what is this one? What is this one? This is A and this is now B. Take like that, right? So for A, you will have 2, because this is a single variable. You will have either 0 or 1, and for B it will be 0 or 1. And if it is 0, then you put A bar, and if it is 1, then you put A. And if it is 0, then you put B bar, and if it is 1, then you put B. That's all. And now, where you see 1, so for 0, 0, you are seeing it is 0, right? Which means, what is this one actually? This is A bar, B bar. A bar and then B bar. You see these two, 0, 0, 0, 0. What is the output? And you have to put this output inside this particular box. It is 0. Can you understand? 0, 0, it is 0. 0, 0, it is 0. Or on other hand, you can say this is actually A bar, B bar. Right? And if you see this one, this is A bar, this is B. And you see this one, this is A, this is B bar. And this is A, this is B. Try to understand. Wherever you see zeros, you have to put bar. That is what we have seen in the min term and max term, right? This one. Wherever you see 0, you would have put the bars, right? For SOP functions, right? Now you see this one. 0, 1, 0 and then 1, the output is 1. So you have to put 1 here. And 1, 0, this is 1 and this is 0, and you have to put 1 here. And 1, 1, this is 1, this is 1, you have to put 0 here. That's all. This is how you need to write or draw a Karnaugh map for a 2 variable or 2 input system, right? Can you understand what I am saying? Be very careful, because these lectures will give you a good understanding of how to map the particular Boolean expression into the Karnaugh map. It is very important, right? So now we have done for 1 input system and 2 input systems, right? Then we will go for the 3 input system. Now we will go for 3 input system. These are all we know, right? Or 3 variable K-map. They will always call it as 3 variable K-map. Anything it may be, right? So now if it is 3 input system, then obviously you will have A, and then B and then C, right? So we know the shortcuts, right? So we can easily write down. So 8 combinations. So 4 zeros, 4 1, and then 2 0, 2 1, 2 0, 2 1, and this will be 0 1 0 1 0 1 0 1. Right? So now let us we have some y, that means the output. Maybe you take this as 0, this is 1 0 1 1 1 0 1. See, this is arbitrary. This is arbitrary. I'm just taking for an example, right? So there is no combination of this. Why it may be it can be any application. If you are going for full ladder and full subtractor, there are so many arithmetic combinational logic circuits will come, right? Try to understand. I will explain you those kind of things bit later, right? So what it actually means, what is this y right now, and you have to be very careful by writing this y. What is y? And wherever you see this one, you have to write. That's all. That is the Boolean expression. Whatever the Boolean expressions you are getting here, that is actually going to become the output of that particular expression, right? So if you see 1 here, maybe you know the min terms also, right? So you just write the min terms also. This is m0, m1, m2, m3, m4, and then m5. This is m6, this is m7, right? You know the min terms too, right? So you can directly write the min terms. You can directly write the min terms, right? Because what is the output? Whatever you are getting 1 as the output, that is the expression you will get. For example, we will write in both ways, right? So you have 1 here. So what is this one? This is a bar, b bar, c. So this will be a bar, b bar, c. That is the first one. Plus, where you have to see the output as 1. So here you have 1. So it will be a bar, b, c. So it will be a bar, this is b, and then c. Plus, where you see 1 again here. So it will be a, b bar, c bar. This will be a, b bar, and then c bar. Plus, and you see 1 here. So it will be a, b bar, c. So it will be a, b bar, and then c. Plus, you have written all these 3, and you see here 1, right? So it will be a, b, c. See how many ones are here? 1, 2, 3, 4, 5. Then you should have 5 this SOP functions, right? Yeah, for 5 terms you should have 5 terms in this SOP function, right? 1, 2, 3, and then 4, and then 5. That's all. So now this is the Boolean expression, and you need to simplify this Boolean expression into a, maybe you need to simplify this expression into a shorter form. Boolean simplification. That is what we are going to do with the Karnaugh map, and there are so many basic things are there. You have to see pair, octet, and those kind of things. Quad, pair, octet are there, and you need to simplify with those techniques. And we are now just seeing the basics, right? So now you see you have written it as the Boolean expression here. Like, what is this one now? It is in canonical form. It is in canonical form. Or you can write the same expression with m notations too. What is that? Summation m, because this is an SOP function, I have used summation, and you have to put m in brackets. Whatever the thing you have, see here, this one, this is m1, right? m1 is 1, so it will be 1, comma, and m3 is 1, so this is 3, comma, and m4, m5 are there, so 4, comma, 5, comma, and then 7. That's all. You have represented this particular truth table into Boolean expressions in terms of normal Boolean expression as well as in terms of min terms. That is the whole idea, right? Now, if it is a 3 input system, then you will have 8 number of combinations, right? So the Karnaugh map now it becomes 8 variable, 8 number of combinations for 3 variable. So you have to draw like this. You have to draw. See, these are all very basics. Please try to be with me so that you can easily understand while solving the Boolean expressions, right? Now you have to split like this. You have to split like this. 1, 2, and then this is 3. So now you see there are 8 number of combinations are there, and you can split like this now, and you just write you take this as A and this as now B. Okay. So now if it is A, then it will be 0 or it will be 1 because this is a single one, right? So not this one is CBC because you have A, B, C, right? So this will be now A bar and this will be now A because you have to put bar for A, bar for 0, right? And BC is here. Now you have to write the numbers here. So if it is two input system, for example, if it is a two input system, what is the combination you will have for two input system? It is 0 0 0 1 1 0 1 1, right? Now what is the thing you have to be understand here? I have told you what is gray code, right? What is gray code? In successive numbers, one bit change will be there. And you see here 0 0 is a, this 0 is came as it is, but this 0 is converted to 1. So no problem. This is correct. This is satisfying the gray code principle. But you see here, this is 0 1. This 0 is converted to 1 and this 1 is also converted to 0. And from here to here, the gray code is not satisfied. So what we will generally do, we will write like this 0 0 0 1 1 1 1 0. Now you try to understand. This 0 has came as it is, but this 0 has converted to 1. So 1 bit change. So obviously this is satisfying the gray code, right? This is satisfying the gray code. And you see here from here, this 0 is converted to 1, but this 1 is coming as 1. So from here to here, this is also satisfying the gray code. And you see here, from here to here, from this particular input to this particular input, this is 1 is came as it is, but this 1 is becomes 0 here. So 1 bit change. Again, this particular successive numbers as satisfying the gray code. So we generally write this is 0 0, this is 0 1, not 1 0. We will put 1 1 and then 1 0. Can you understand? That is why I have told you, you have to see this gray code. Basics of gray code will help you while writing the Karnaugh map. Right? How will you write this one now? This is now B bar and then C bar. This is now B bar and then C. This is B and then C. This is B and then C bar. Wherever you have 0, you put bars, right? Now this is how you have to represent the K-map. And also you can write the min terms here. How will you write the min terms? How will you write the min terms? What is this one now? This is actually A bar, B bar, C bar, and this is A bar, B bar, C. I'm just writing this one. I'm just writing this one, right? This is A bar, B, C bar, and this is A bar, B, C, and this is A, B bar, C bar, and this is A, B bar, C, right? This one is A, B, C bar, A, B, C bar, and this is A, B, C. Right? So now you see here, wherever you see A bar, B bar, C, you put 0. You don't need to put M because I can easily understand if it is B, C bar, then it is multiplication, then obviously this will be a SOP function, right? So you see here, A bar, B bar, C, how will you find? This is A bar, and where is B bar, C? Where is B bar, C? I mean, made any mistakes? Okay, fine. This is A bar, B bar, C bar, right? All the three variables are 0. See here. So A bar, B bar, C bar, you have to find. This is A bar and this is B bar, C bar, right? And what is this min term? It is 0. So put 0 here. Put 0 here. That is the first one, right? So you have done this one. And what is the next one? A bar, B bar, C, right? So A bar is here. Where is B bar, C? It is here, right? So what is the min term? It is 1. So put here. The 1 you have to put here, right? And then the third one, A bar B. A bar is here, we have seen. And then B bar C you have to see, right? So B C bar, right? B C bar is where? It is B C bar is here. And what is the min term? Min term is 2. I have to put here, not here. Try to understand. That is why I am doing this one. And for min term M3, it is A bar B C. A bar is here, B C is here. So you put 3 here. And then everything A, B bar, C, right? A, B bar, C, it is min term number 4. A, B bar, C. So min term 4 I have to put here, and then M5. So it will be A, B bar, C, right? So A, B bar C. So min term 5 I have to put here. And M6 A B C bar. A B C bar is here, not here. So the min term 6 it has to come here, and then A B C the min term 7 it has to come here. So this is how you have to write the Karnaugh map. What are all this one? This is the min terms. These are all min terms. Always min terms. It will be like 0, 1, 2, 3, 4, 5, 6, 7. Right? It will come like that. Right? So for example, you have to map this output right now. So how will you map the output now? So for min term 0, it is 0. For min term 0, it is 0. So put 0 straight away. You don't need to see A bar, B bar, C now. If you put min terms, then it will be easy to map the outputs. That is why I always use min terms. Rather use the expression, I always try to use the min terms. Even if the question is given with the expression like this Boolean expression, I will not use the Boolean expression. I try to write the min terms and I will write the output with the min term. That is very simple too. So M1 is 1. So it is 1, M2 is 0, so 2 is 0, and 3 is 1, I have to put 1, M4 is 1, M5 is 1, M6 is 0, so 6 is 0, and 7 is 1. That's all. So now we have just written this particular truth table into the Karnaugh map. That is why I have written here. Wherever you see 1, 3, 4, 5, 7, you have to put 1. Or for all others, it will be 0. See here, for 1, I have put 1. This is 1, I have put 1. And for 3, I have put 1. And for 4, I have put 1. And for 5, I have put 1. And for 7, I have put 1. All other terms are 0. That is what this particular function, this particular minterm representation explains you. These outputs are 1. All other outputs are 0. The combination of outputs are 0. That is the whole idea, right? So now we will go for the 4 input system. So we will go a bit faster now because we know, right? So 4 input system, right? So I will just write down the A, B, C, D, those 16 number of combinations, right? I don't need to waste time. Right. Now you see, I have just taken the 4 input system, right? So 4 input system, there are 16 number of combinations are there. And how will you write the expression for this one? What is the expression? This is all bars, right? Everything is 0. So it will be A bar, B bar, C bar, D bar, simply. And then this will be A bar, B bar, C bar, D. Like that, you have to write for all the inputs, right? So, right now you see, I have just written for all the combination, and this is which is nothing but we can say this is M0, this is M1, this is M2, this is M3, and M4, M5, this is M6, M7, M8, M9, this is M10, this is M11, this is M12, this is M13, this is M14, this is M15. Right, so I have written the min terms too. I have taken an arbitrary output. Arbitrary output, it is not meant to any logic circuit. So now it is a 4 variable K-map system. So you have to draw a 16 number of combination table, right? A 16 number of combination table. So I will take a big thing like this so that it will be easy to understand. 16 number of combination table I have to draw now. So how can I draw? So this is 1, 2, 3. This is how. So now this will be 1, and then 2, and then this will be 3. So now you can just split this one. See here, you try to write this as AB now and this as CD because 4 inputs are there, AB and then CD. So this is 2. So the combination will be 0, 0. And then 0, 1. See, this is gray code. So you have to put 1, 1 and then 1, 0. Try to understand. That is what we have done here. Whatever we have 0, 0, 0, 1, 1, 1, 1, 0. Like that 0, 0, 0, 1, 1, 1, 1, 0. And also here you have to put this is 0, 0, 0, 1, 1, 1, 1, 0. Right? So now what you do? You just write down the expression. This is A bar, B bar, and this is A bar B, and this is A B. This is A B bar. Try to understand. Right? I have just written for this one, and for this one, this is C bar D bar. This is C bar D. This is C D, and this will be C D bar. Try to understand. Right now, I will give you the shortcut method to write the min terms. You just try to verify that, right? So see here, I will write the min terms number for every box. This is 0, this is 1, this is 2, this is 3. That is we know, right? From here, 0, 1, 2, 3, right? And for also, this is 4, this is 5, this is 6, and then this is 7. Try to understand. I am not going to start it because I have 15 numbers here. I am not going to start 8 here. Why? Why? Because 1 is coming here, 1 0 is coming here. So obviously 8 will come here, 9 will come here, 10 will come here, 11 is here, and then 12, 13, this is 14, this is 15. Try to understand. And if you want to verify anything, see here, 12, M12 is what? A, B, C bar, D bar, right? So A, B is here, C bar, D bar is here. Then 12 will come here, 12 will come here. You verify some other thing, maybe you take M10, A, B bar, C, D bar. A, B bar is here, C, D bar is here, right? A, B bar, where is A, B bar is here, C, D bar is here. So A, B bar, C, D bar, 10. So that 10 I have written here. Can you understand? Please try to understand. 0, 1, 2, 3. We know this one. 4, 5, 6, 7. We know this one from the 3 variable K-map. And I don't need to, I should not put 8 here. Instead, I have to come here. Why? Because I have changed these two. Because this is not 1, 0, 1, 1. This is 1, 1, 1, 0. So 8, 9, 10, 11, 12, 13, 14, 15. That's all. Now I need to map. Which one? M2 is 1, right? So straight away you can put M2 is 1. So 2 is 1, and then 3 is 1, and then 6, 7 is 1. So 6, 7 is 1, and then 10, 11 is 1. So 10, 11 is 1, and then 14, 15 is 1. That's all. All other terms are zeros. All other terms are zeros. 0, 0, 0, 0, 0, 0. And simply, what is the y expression here? Summation m, that is equal to whichever term you have 1, you have to put here. 2, 3, 5, 6, 7, and then 10, 11, 10, 11, 14, 15. 14, 15. Actually, this is the Boolean expression in terms of min terms. Try to understand. That is what we have mapped here. That is what we have mapped here, right? So this is how you need to map a 4 input system, 4 variable system K-map, right? So if you want to write the expression, then what will be the expression? You take this one, 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 right? You just add this or add all these expressions. This one plus this one plus this plus this plus this plus this plus this plus that is what the y expression you will have. Right? This is how you need to express a 4 variable K-map, right? So we have started today with the basics of Karnaugh map, and in basics of Karnaugh map we are going to use the gray code. In successive numbers, 1 bit change will be available in gray code, and that codes are we are calling gray codes, right? And then we have seen for 1 input system and how to draw the Karnaugh map, and for 2 input system how to draw the Karnaugh map, and 3 input system. Here we have seen the min terms also, so how to represent the min terms in the Karnaugh map as well. So we just try to use the gray codes, right? So we always put 0 0 0 1 1 1 and then 1 0 in the Karnaugh map, because the Karnaugh map always follows the gray code technique. So we have just written this one, and we have gone for 4 input system, and we have just taken this table. The 4 input means 16 combinations are there, and then we have written here, right? Thank you.